This problem deals with similar triangles. In the figure shown below, triangle ABC, the larger triangle with vertices ABC, is said to be similar to, this symbol means is similar to, triangle ADE, which is the smaller triangle that makes up the top of this figure. The question is, what is the length of side AE? I'll label side AE with an X. Realize this is the distance just from the vertex A to the vertex E. To solve this problem, we're going to need to use a property of similar triangles, which states corresponding parts of similar triangles are proportional. What is meant by corresponding parts is, if I take a look at the base of the smaller triangle and compare that to the part of the triangle that's labeled X, side AE, if I write that as a ratio, 6 to X, so the base of the triangle as a ratio to the segment AE, which I've labeled as an X, that's proportional to, that's equal to the ratio of the same corresponding parts in the larger similar triangle. Now the base of the larger triangle is 9, and the side of the larger triangle that corresponds to 6 to X would be the entire length from A to C, which in terms of X is X plus 3. Because I know that these two triangles are similar, I can set up this proportion. 6 to X is equal to 9 to X plus 3. Perhaps the hardest part of this problem is setting up this proportion, because once I do, the proportion can be solved by cross multiplying. 6 times X plus 3 is equal to X times 9, which I'll write as 9X. Solving for X, I'll distribute the 6 first, which yields 6X plus 18. I'll subtract 6X from both sides of this equation to find that 18 is equal to 3X. And then finally, by dividing both sides of the equation by 3, I find that X equals 6. In this figure, the length of segment AE, which I've labeled side X, is equal to exactly 6.